So let's start this session. My name is Andreas Dieckow. I'm just going to introduce the presenter for this presentation. A few weeks or months ago, actually, our sales team contacted me as I was preparing for all the sessions for the Solution Developers Conference that there is a customer that has a really, really cool presentation. And normally we don't have customers speaking at this conference, and so we were glad enough to have a session set up with André, and we were very excited about having this session and him doing it. So he's from Canada, the French side of Canada, works for a large hospital, more than 7,000 employees, over 1,000 physicians in the area. So this is not a small installation. This is very substantial. He graduated in 2007 with computer engineering, works at the current hospital since 2012.
Right.
And is really looking into everything related to like source code control, testing, how to get things done faster and more efficient. So with this, I would like to introduce André to him, and I wish you fun with your presentation.
Thank you. So thank you, Andreas. Good afternoon, everyone. Thank you for joining us today. I'm André-Claude Gendron, and like Andreas just told you, I'm involved in the software development group at the CIUS de l'Estrie CIUS. At CIUS, we are using InterSystem Cache since 2010, extensively in many aspects of our daily work, and we are using the Zen framework, the Ensemble engine, as well as the cache database itself. The cache line of product is our Swiss knife. We do everything with it. Today I make a brief presentation of the mocking framework we've developed and used extensively over the past 2 years as part of our quality control process. So I'll start by a short programming background refresh, and then I'll show you what we've created and how it works. I'll then show you atelier screenshots to show you a few code samples. And at the end of the week, the presented code will be made available on the InterSystems developer community. And we hope you'll adopt that way of unit testing and will contribute to the future growth of this library. So without further ado, let's begin by a quick programming background refresh. One of the key concepts at the heart of our development process is unit testing at CIUS. A unit test is a small chunk of code used to validate the behavior of a function or an object. It indicates if the individual parts of an object works in every required scenario and provides, in a way, a strict contract that the tested object must satisfy. A unit test has to be simple to execute and ideally should run every time a change occurs in the code base. This helps find a problem early in the development process and also helps to deal with change. By that, I mean that it is much easier to replace or fix a function on an object and to be sure that every documented scenario still works. Another key programming concept required to understand the usefulness of a mocking framework is the design pattern called the inversion of control. The most common implementation of this is through dependency injection. For instance, assume we have the following class A, which uses two services, the service A and service B. The class A creates an instance of service A and service B and calls them when required. The dependency injection works differently. Your main application, called the builder, starts by creating an instance of service A and service B and injects them into the class A. This is usually done through the constructor method. And we'll see two examples of that later on. The most important thing to notice here is that the class A does not instantiate its dependencies, the service A and B itself. The class A receives those dependencies ready to use. The last programming concept required to understand how the mocking framework works is the mock object itself. A mock object is an object that exposes the same interface as another object, but returns controlled output. The mock object expects to receive calls in a precise order with specified parameters and will return precise values. Sometimes there is confusion in different ways of unit testing. You perhaps have heard of stubs, fakes, or mocks. Each of those has their own purpose and test differently a class. So while I'm here to present you a mocking framework, I'm not saying that it is better than any other way of unit testing. It's just another tool to add to your tool set. So if we bundle all those concepts together, we end up with this. In a unit test, acting as a builder, you create required mock objects and them into the class A, the class. By controlling those mock services, we are easily able to simulate every required scenario easily, such as network error, database write error, license problems, server unreachable, etc. So while the builder is the unit test itself, in the deploy environment, we found ways to have those automatically created without the need of a specific builder class. This is especially useful for unit testing Ensemble classes. So like I previously said, we built a comprehensive mocking framework used for unit testing of cache object script classes, Ensemble classes. So for instance, if you have a calculator service that you want to test, which uses a math library, you create a mock object of that math library, and using the unit test, you inject it into the calculator service. That way, the calculator service does not have to have a working math library to work. It is controlled by the unit test. It will be much clearer in the examples, I expect. You can also mock SQL requests. You can mock the Zen reports data source. And we found all of those features useful to test many different classes. This is another very visual representation of how a mock object interact with a tested class. So in your real system, you would have every piece of software bundled together to form a beautiful large image. But when you're unit testing stuff, you want to piece them in precise, you just want to test a specific piece. So you create all the interfaces required around that piece, and using mock objects, you can control all of those yellow pieces in order to test the green one. So let's start by a quick, simple, real-world example. Here, we have a regular class with a sum operation. You instantiate a class, a service here, and you call the method add on it. This is a very simple implementation. And that's the implementation of the math service. So you have a add function returning an integer and just quit the sum of A plus B. And there's also a note left by the math intern to do implement division someday. So this will be done later on. For now, it does not exist. So if we would do a unit test of this, a unit test, you would create an instance of the tested class, and you would create some test methods here with an assertion. So you assert that when you call the tested class sum operation with the parameter 1 and 2, you expect to receive the value 3, the result 3. And if you would run that unit test, you would get a passed test, and all the tests of those class would pass. So if, for whatever reason, the math intern changed the implementation of the math service, then if we would run the same test, it would fail. This makes me sad because the implementation of the class did not change. Our implementation is still correct. However, our dependency changed, and because of that, our unit test now fails. So if that math service would be used at many places, we would have a ton of red, and we don't want that. We want to have at least the less red possible in order to quickly isolate where the error comes from. So if I would do the same example, but using mock object instead. First, I need to make some cosmetical change to the class. Instead of directly calling the math service, I would have to, on the constructor method, receive a mat service. You could also do a default implementation in case no mat service is provided. You set it as a local property, and then when the sum operation is called, the mat service is then called. So by comparison, here was the previous implementation. So the sum operation does pretty much the same thing, except now it's a local property that is called. So if you would create a mock object or a test of this unit test, a unit test of this tested class using mock, you would create a mat service and tells it that it's a mock. So you create all the dependencies. You inject them in the constructor method. And then you record expectation objects. I'll go more deeper in that later on. Then you put the mock manager in replay mode. You execute the tested class. And then you verify if there's any outstanding issues. So here, simple class. I create a mock of a mat service. I inject them in my onBefore1 test. So that's the preparation method of each unit test. And then in my tested sum operation, like I've previously shown, you expect that the mat service will be called the method called add, with the parameter 1 being 1 and the second parameter being 2. And you expect to, and you wish to receive 3 as a return value. I've put it in replay mode, and I call the same assertion as before. So that's really the same call here is done. And I verify that all mocks are correct. So obviously this was a very simple example just to display how those stuff work. So if I go into a more useful example, here I have a more complex operation implemented by my class. I'm calling the mat service and I'm having a look if A is greater than B, I would call the divide operation, and else I would multiply them. If we recall, there was a comment in the mat service because the division was not yet implemented, and the multiply aren't either, and the greater than neither. So this would be bad for a regular implementation because we could not complete our test before those dependencies are completed. But with mock objects, we don't care at all. We just expect the parameter here. The mat service will be called greater than with parameters 6 and 2, and then return 1 or true. And then we expect that the mat service would be called divide with 6 and 2. And also, if I go back, you'll notice that there was a by reference status here, which was returned by the complex operation. So here, you expect to receive a by ref parameter. The input value should be OK, and the resultant value after the call should be the expected status here, which is still OK. And then return an arbitrary value, 50. This does not have to be the real result of the division, because the division perhaps is a very complex operation, and you don't have to know all the internal, how to know the exact implementation of this. The only thing that matters to you is that once this value is returned by the divide operation, you want to receive it when you call the complex operation. So this can help you return much simpler value. So then I put my mocks in replay mode. I test the complex operation with my provided parameter. I've asserted that my return status is still OK, and I verify that all went well. If I would do the multiply, here 6 and 2, and I return 0 instead of 1, so I return false, I can verify that it's the multiply that is called instead of the divide operation. Yeah. So let's recap. A mock replaces a dependency by a control object that you inject into a tested class to isolate it from its dependencies. By controlling yourself the precise output of each dependency call, you are able to simulate every possible scenario, even complex one. I kept this for the end because we found this awesome. Many Ensemble classes can be tested, can't be tested outside of a production using regular methods. However, using the unit framework, the mocking framework, it's much easier. This saved us so much time when developing our custom business processes and custom business operations. It also made possible to unit test those classes without any running production. So if we think about it, Ensemble classes code have a few dependencies. They mostly depend on the base class methods, such as send, request, async, or so on. You are familiar with it. Or their adapter in case of service and operations. An adapter is just a dependency. It can be injected if needed. So here, I have a basic class that inherits an Ensemble class. I've overridden the constructor by making possible to specify an adapter override, which is null by default. And if any adapter override is given, I replace the current class adapter by my overridden adapter. That way, I can create a mock object instead of my adapter, inject it into my tested class. I can set the various parameters of my operation. For here, I used a operation file name. And I can control this adapter, how it will behave. So here I expect that the adapter will be asked by the onMessage method the file path. It should return ctemp. It will be called create file name. So for you who have dug into the file pass-through adapter, you have some parameters that can be replaced for dates and path and so on. So that's the call create file name. And then the adapter will be called put stream with the content, the proper content. And you can return if the put stream failed. So here I simulated it failed with a whatever error, put stream failed. And I expect here that my status is not OK. A process also has dependencies. A custom business process works the same way. We can do a small act to the constructor method in order to inject a control-based class method. And instead of directly calling on send, send request async, we call the Ensemble process we've injected. By default, it worth this, a $this pointer value. And you can then and then you can then replace that business process by a mock that you inject into the process, and then you're able to simulate it. You expect that the send request async method with whatever target you've defined will be called and should return OK. So this work was only possible because of the provided percent unit test framework of cache. What we've built is built on top of it. We also found the additions created by the development team, Sergei here, presented at the Summit 2015, very useful for local development of unit tests. So the following demo was a combination of all those software pieced together. The code of this presentation, as well as dozen examples, will be given to the InterSystem community as soon as possible, most likely by the end of this week. We hope you'll develop with it and you will like it. Hopefully you'll contribute to its development. It is nice, but can for sure be enhanced and be great. Thank you for your attention. I hope you enjoyed this short presentation and that you'll like to use and perhaps contribute to this library. It is powerful stuff, I can tell you. We now have quite a long period of time. I spoke quickly. For questions, I can go back into some code samples if you wish. Yeah.
We would like to see the library class.
Which?
The library class for this one, which we created.
Yeah, everything that I've displayed today will be available in the package that I'm going to share. There are dozens of examples. Those ones are in there, but they are much more complex with it. There are tests or examples of SQL injected instead of regular SQL call. There are examples of Ensemble classes, examples of business process, business operation. Almost everything that is supported by the framework we've built is demoed in that. Yes?
So how do you use this library yourself? How many tests do you have or tests of your application?
Yeah, there's only, in fact, we've built a unit test class that overrides the % unit test, so it just adds feature to it. So there's only a couple class you need to import, and you compile them. And when you create your test here, instead of inheriting % unit test, you inherit the test framework.c unit test base. So you'll get everything that you need by inheriting that. The rest of the stuff, like the on-before-one test, is already built into InterSystem. We've created a helper called run test, which helps when running a unit test in the debugger. So you just right-click on that, execute in debugger, and then you're able to break into your unit test and test the implementation that you're testing.
My question was more about how do you use it in your company. So what aspects of your application, of your company do you test, and how many tests do you have for your application?
I don't know about the number of assertions, but we have a few hundred classes that are unit tested. Every new classes from the last 2 years needs to be unit tested, at least partially. We have some liberties given us by management to spend time doing unit testing. So far, it's been very useful. We're glad we've done it. Previously we were doing every test was done by hand. So each time a change was made into the code base, we would run 100 hours of manual testing of every scenario. So we now have unit tests. We have also integration tests, which are able to test a whole production at once by simulating the input and the outputs. We have each time a new scenario comes in from support that we need to maintain because there's a bug in it, we enhance the unit test to make sure that it's covered and it will not come back later on. We do not have yet a continuous integration or continuous delivery loop. We wish to, and as a participant to the summit, I'll go to the Tech Exchange group to talk about that and to you specifically, because that's something we want to move to. Now, each time a user does a commit or he or she has to run all the unit tests and the integration tests by hand on his own machine. It takes a few minutes, covers a few thousand scenarios, but it's not automated completely yet.
One more question.
Yep.
So basically, here we have coded in the red test class, this code. So internally, the new class what you have created is also calling the red test class for the percentage test class, the percentage test class.
I'm not sure I got the question.
So my question is that here basically we have overridden the red test class of percentage test.test case class, right?
Yes.
Yes. So in your new class, whether we are again, you are again calling the hashes super for the person.
Yes, that's because here, the hashtag super here, that's because the constructor new of the base class here, the business process, does many stuff in Ensemble. It registers them into the production. It does many stuff I don't know about, in fact. But without that, it does not work in a production. So we added that. I can't go into the very specific details, but it needed to be done in order to work. This is just a small increment stuff we add, but we don't want to replace the old constructor method of the object. We just enhance it in a way. By the way, this ..ends process here that we've injected, at first it is bad because you have to change your implementation code in order to test it, which is usually not the best practice. However, we found that this actually made the code simpler to use. When you're trying to find an implementation where the messages are exchanged between different Ensemble config items, you just look for the ..ns process, and then you found every async call, or whatever. It makes easy to find them into your mostly often large business operation, custom business process, or custom business operations. Any other question? Yes? It can be improved in many ways. It does not yet support REST calls, either in or out. While we could find ways to make it work. This is more like the SQL implementation. We're using globals to hide stuff, and when the SQL is called, we replace the proper call by that. So we could use that for REST, like simulate a small REST server with you should receive this call and give back this answer once called. For now, we've done this using stubs or fakes instead of mock. It works, but it's not pretty because all this mock stuff is based on a mock manager class, and that class lives inside the unit test process when running. So there's no inter-process communication occurring during that unit test execution. So we cannot be aware of something occurring in another process or another thread easily. We can do it through globals, there's many ways to cache to do that, but for now we've not done that. Any other questions? We still have 15 minutes. Okay, so I'll be sharing that code as soon as possible on the developer community. I will create a Git repository in that, so you'll be able to pull it, clone it, enhance it. You can use it freely as you want. We wish that the enhancements you do are pushed into that library, so we can everyone can benefit from those enhancements. You'll find that the user documentation is quite thin. It was not our initial idea to share this, but there are so many benefits to open the source other people that we decided to go to open it. Okay, well, thank you very much for your attention, and